So learning objectives for this segment will be to calculate the theoretical yield of a reaction and to calculate a yield of the reaction. So the theoretical yield is just the total amount you could get out. Given the circumstances for the reaction, if you'll have one component, and if it reacts, you're given one component. If it reacts completely, how much will you get? That is the total possible yield you can get. Now, in practice, you never actually get that amount. There could be side reactions that occur. Just because we write down one reaction doesn't mean there's other reactions that can't be occurring. And also, you'll get stuff that will be sticking to the side of your beaker. When you do the separation, something will stick on the filter paper. So you never get 100% yield. Usually the biggest reason you get poor yield is because of side reactions, but definitely messiness in collecting everything will be part of it as well. Okay, so let's do some examples of how we do this. So PCl3 reacts violently with water to form phosphorus acid, which is H3PO3, and hydrogen chloride. So how many grams of hydrogen chloride are formed if 8.0 grams of PCl3 are reacted completely with water? So that should tell us that there's more than enough water. So the extent of reaction is going to be determined only by the amount of PCl3. Okay, so let's write down the equation. So we write down the equation, and that would be PCl3 plus H2O goes to H3PO3 plus HCl, and we'll do our algebraic way of balancing the equations, just for good practice, A, B, C, D. For this problem, it doesn't really matter how you do it as long as you get balanced reactions at the end, but we'll do it, we'll do the algebra just for practice. So the phosphorus equation is, there's phosphorus, there's one in A, so A equals C, and then for chlorine, there's 3 in PCl3, so 3A is equal to D. For oxygen, we get B, 1 from water, is equal to 3, because there's 3 in 3C, there's 3 in H3PO3. And for H, we got 2B 2B is equal to 3C plus D. All right, so let's assume that A is 1. Why not? So if A is 1, C is 1. A equals 1, C equals 1. Ooh, halfway done already. Isn't that great? And even easier. So O would B is equal to 3C, so B is equal to 3. So we got oxygens as well. We got B equals 3. And guess what? We don't even need to use the last equation because we know A, and D equals 3 times A is 1, so D equals 3. So you could say, but I've got this other equation here. What do I do with this other equation if I already have all the variables solved? Well, let's see. So 2B, that's 6, is equal to 3C. C is 1, so that's 3 plus 3. It's just redundant information. So sometimes you might have more equations than there is information, but they will be consistent. If you solve it through, you get all the variables. Any additional equations will just help you verify it. Okay, so we've got our balanced chemical equation. We've got, this is 1, this is 3, this is 3, this is 1. Fantastic. So what do we need to know now? Well, we want to figure out how many moles of PCl3 there are. So the molar mass, and we're going to, molar mass, let's do this first. Molar mass of PCl3 is just going to be, looking up at our periodic table, it's going to be 30.97 plus 3 times 35.453, and that gives a molar mass of 137.33. That's grams of PCl3. Okay, think of this as a molar mass as a conversion factor. Cl3 divided by 1 mole of PCl3. And so, therefore, we take 8.0 grams of PCl3 and convert it into moles. Well, 137.33 grams of PCl3 equivalent to 1 mole PCl3. And now we know from the balanced chemical reaction that 1 mole of PCl3 produces how much HCl? It produces oh, okay, I was getting confused because I wrote down my variables wrong. That's always one thing you can do. You probably caught that already, but C is 1 and D is 3. There we go. So it's 3 moles. So if you caught that before, you probably did. Good. 3 moles of HCl. And now, if we look at the cancellation now, grams, PCl3, PCl3, grams of PCl3, 1 mole of PCl3, mole of PCl3. That gives us moles of HCl, but we don't want moles, we want grams of HCl. So we need the conversion factor between moles to grams, which is also the molar mass. So molar mass of HCl is going to be 35.453 plus 1.008. That gives us 36.461 grams of HCl per mole of HCl, right? It's a conversion factor. So 1 mole HCl and 36.461 grams of HCl. So this cancels and we plug everything in, we get 6.372 grams of HCl, but there's only 2 significant digits because we only knew that there was 8.0 grams to begin with. So we would round that to 6.4 grams of HCl. Okay, so there we go. So that would be the grams of HCl we get. That is the theoretical yield of this reaction. Okay, so we've got the theoretical yield. How to know the actual yield? Well, you need more information. You don't know any actual yield at this point. You'd be given the amount you actually got, and then you could figure out what the actual yield was. So, if the reaction we saw on the previous page was stopped early and only 5.5 grams of HCl was formed, what is the yield? So in this case, this is pretty straightforward. We just need to take the number of grams that was produced, 5.5 grams of HCl, 6.4 grams of HCl, and that gives us 0.859, and that would be 86%, an 86% yield. Actual yield is as simple as that. Usually the only problem is you need to figure out the theoretical yield before you can figure out the actual yield, once you're given the yield in amount from the previous example. So